Vehicle warning lights are critical safety indicators that communicate the status of your car's safety systems. Understanding what these lights mean can prevent dangerous situations and costly repairs. The traction control light has three distinct behaviors that indicate different system states. A solid light means the system is actively working or has been temporarily disabled by the driver. A flashing traction control light indicates the system is actively engaging to prevent wheel slip. This happens when the system detects loss of traction and is working to regain control. When the traction control light stays on constantly, it signals a system malfunction or that the system has been manually deactivated. This requires immediate attention. Brake warning lights come in different types, each indicating specific issues. The red brake light is the most critical, signaling low brake fluid, an engaged parking brake, or complete system failure. The ABS light specifically indicates a malfunction in the anti-lock braking system. While your regular brakes may still work, the anti-lock function that prevents wheel lockup during emergency braking may be compromised. These warning systems depend on several key components working together. Wheel speed sensors monitor the rotation of each wheel and are critical for both traction control and ABS operation. The brake fluid reservoir maintains hydraulic pressure throughout the system. Low brake fluid is one of the most common causes of warning lights and affects both braking performance and traction control operation. The electronic control module, or ECM, serves as the brain of these systems, processing sensor data and coordinating responses between traction control, ABS, and other safety systems. Modern vehicles integrate traction control with advanced safety systems. Electronic stability control works with traction control to prevent skidding and maintain vehicle stability during turns and emergency maneuvers. These interconnected systems work together as advanced driver assistance systems, or ADAS, providing comprehensive vehicle safety. When multiple warning lights appear together, it often indicates problems affecting several interconnected systems simultaneously. Start troubleshooting by performing three critical initial checks. First, ensure the parking brake is fully released, as this is often overlooked but commonly triggers brake warning lights. Second, inspect the brake fluid level in the reservoir. Low brake fluid is the most common cause of both brake and traction control warning lights, as these systems share hydraulic components. Third, perform a visual inspection, looking for obvious leaks, damaged components, or loose connections. Also check battery voltage, as low voltage can trigger false warning lights. If initial checks don't reveal the problem, move to diagnostic scanning using an OBD2 scanner to retrieve fault codes from the vehicle's electronic control module. Use an OBD2 scanner to connect to your vehicle's diagnostic port and retrieve fault codes. Modern scanners can identify specific system malfunctions and guide your repair efforts. Common fault codes include C035 through C040 for wheel speed sensor issues, C0265 for electronic brake control module faults, C0550 for ECU malfunction, and U0415 for communication errors between modules. After identifying fault codes, proceed to component-specific testing to pinpoint the exact problem. This involves testing wheel speed sensors and inspecting brake system components. Test wheel speed sensors using a multimeter. Check resistance values, which should typically read between 1,000 and 1,400 ohms. Also test for proper AC voltage signal output when the wheel rotates. Inspect brake system components, including fluid quality, brake pad wear, and rotor condition. Contaminated fluid, excessive pad wear, or warped rotors can all affect sensor readings and trigger warning lights. Once you've identified and addressed the root cause, you can reset the warning lights using two primary methods: battery disconnect or OBD scanner reset. The first reset method is battery disconnect. Remove the negative battery terminal for 15 minutes, then reconnect and start the engine. Drive at low speeds to allow the system to recalibrate. The second method uses an OBD scanner to clear fault codes and perform system relearn procedures. This is often more effective as it can reset specific system parameters and verify the repair. Understanding success rates and maintenance requirements helps set realistic expectations and prevent future issues. Professional diagnosis takes an average of 1.2 hours. DIY repair success rate is only 45%, while professional repairs achieve 94% success. This highlights the complexity of modern vehicle systems. Prevent future issues with regular maintenance. Replace brake fluid every 2 to 3 years. Perform annual sensor cleaning. Check for software updates, and maintain proper battery voltage above 12.6 volts. While basic troubleshooting can be performed by vehicle owners, the complexity of modern integrated systems often requires professional diagnosis for persistent or complex problems. Early intervention and regular maintenance remain the most cost-effective approaches.